Hi my friends, let's model the part number 93, flanged valve body, from my collection of 100 parts. The picture is very nice, as you can see, and it has three threads gauze. So we have to use diameters from the file in Inventor. You'll find all the data in the drawing. Here you have details. Yes, I made an extract for you with these diameters, and you can find them in this file from your directory on your disk where you installed Inventor. Here you must use the number of your installation. Yes, that's all. Explanations you can find in my tutorials number 060 and the other. Let's see what is this about. The complicated aspect is about this wall. This is placed in the middle of an ovoid hollow, and we have no other possibility but creating another body, a body with this and a body with the rest, and then to combine them in one single volume. Let's start with constructing this wall. Dimensions are in the drawing, and you can consult it anytime from the clip. The sketch is placed in the XY plane, and I draw that these are parallel, so I accept, yes, to be parallel. These are also parallel, and close. Yes. Now let's place dimensions, but the first thing I want to make is to apply parameters. You can find them in tools, not in tools, in manage. This, if you apply add to quick access toolbar, you will find here, as I did. So we remain in this ribbon, and I activate this. I create the a new parameter, user parameter, with the name dia flange. Dia flange. DIA-FLANGE. Yes, with the value of 88. Done. Why 88? As you can see, this must be placed somewhere, and the maximum dimension here is this 88. We'll use it when we construct this volume, but now we work here, and I need to have maximum limit diameter. in my construction. Good. Dimensions are 5, also 5, and 6. 6. Other dimensions are as in the drawing. 36 divided by 2, and the same, because this is symmetrical in a way, I select the same value, and this is placed in the middle, so this is the 2 divided by 2. Good. The angle is 45. Well, and now I use that dimension, the distance between these 2 points. I'll take from the parameters, yes, as you can see. The only parameter is dia flange, created by me, and I use it. This must be equal, this line with this line. You will see that this will be cutted, yes. So I take advantage to have a dimension, a large dimension in the drawing. Finish sketch. We extrude this symmetrical on 66.5 multiplied by 2, a very large, but you'll see why. Next is another sketch with an arc like this, with its ends on the same horizontal with the center point, and with the center point placed on the same vertical with the center of the arc. Radius 66.5, and position at 26. I draw a center line here to apply revolve. Finish sketch, revolve, and now I use intersect, yes, to limit the new volume inside that ovoid. I want to place this somewhere in the back. Move bodies. I move this body direction X on -222. Yes? Okay. Home. The axis, the system is in another. I make them visible for you. And here we'll create the other volume, yes? Now I make this not visible, and you will remember where is this placed. The new sketch for the new volume is in this plane, and the contour is this external. You have to keep in your mind that this thread has this dimension 41.91. yes, we'll create this diameter and then we apply thread. This contour all over, dimensions are here, line, this is the flange with that diameter. I will use it immediately. Close. This line is center line. That diameter is from the parameters, list parameters, dia flange. Okay. Now we draw an arc with these two ends on the same horizontal, and the radius 66.5. Good. These points and these ends are on the superior line. This distance is 26, but the same vertical with the center point. Trim, not trim, split to make this construction, and then we place this over the center point, and dimensions 20, they are in the drawing, yes, 5, 10, length, total length of 225, and the distance from here to the center point of 110. Diameters. This is 41.91 for that gas thread. This is 39, and the last is this diameter of 46. Good. Finish sketch. Volume. Revolve, but we create another solid. Yes, this is the new solid. Okay. We have two solids now, yes, solid 2 and solid 3. We can identify them very easily. Okay, let's continue with developing this volume till we have an interior to combine with this. Now we create this revolving feature with dimensions 56, another diameter for threading, gauge 2 inches, 59.614. Let's create the same plane, F7. You will notice that I create firstly only external volumes, yes, and then internal. What is this? A mistake. This is a small mistake. Dimensions. This diameter is 59.614. This is 120, and this 20. Diameter here is 56. Now is okay. Finish sketch, revolve with the join, yes. I have to select which solid, yes. It is not this one. Now you see with dotted lines two volumes. No, this is not. I'll select my volume. Yes, now you see there are only one volume. Okay. The other one is this one with another gauze fillet which has this diameter 53.746. We create another contour here and the same plane, F7, line, up, left, down, and close. This distance is 72 in the drawing. This line is center line, and the diameter for the gauze thread is 53.746. Okay. This diameter 40. Lengths. This is 55, but the end line must be coincident with the center point, and the other distance is this one, 16. Finish sketch, revolve. Again, we are invited to select combination between this, and we don't accept, and we select this volume. Okay, This is different from this. F6. Next volume is this one, the connection between these two volumes. The diameter is 30 and the distance is 65. We create a sketch, F7, a circle with a diameter of 30 and a placement on the same horizontal with the center point at a distance of 74. Extrude, but again not with this volume. We cut this and we select this. Okay, the next volume is this one, 74 and 65, an extrusion of a circle of 40, symmetrical, because you see this distance, half of this. Good. The plane is this one, F7, a circle in the midpoint of this with a diameter of 40, as I said. Finish sketch, extrude, symmetrical on 60. Oh, and you see it is combined with this volume and not this for the first time. Okay. Next is the interior of this volume, which has this sketch. Radius is 62 instead of 66.5. Let's draw it respecting new sketch, F7, and lines. Line from this midpoint to here, then horizontal up, horizontal up, line, midline, and connection with this. This is a center line, and now diameters. This is 30. The next is 36. The last is 48. Distances 5 and 30. Good. Now we draw an arc which starts from this line, ends to the same line, and the radius is 62. The center of that radius is on the same vertical with the center point, and the distance is 26. Not diameter, 26. complete. Construction. Now we have all the drawing. Oh no, this is not good for some reason. This line is not vertical, you see? Now it is. Good. Finish sketch. Revolve. This with that axis now is connected with the same volume, and cut. Okay. Inside this we have this contour from the center point, which is about here, 44, 40, and another counterbore up. Dimensions are in the drawing, yes? The plane is XY, F7, and lines. Line from here to about this point, horizontal, vertical, horizontal, up, midpoint, and back. This line is center line. This line is not horizontal. Now it is horizontal. Diameters. This is 44. The next is 40. And the last is 46. Dimensions. This is 3. This is 20. And that's all. Finish sketch. Revolve. Again, the same volume, not this one. Cut. Okay. Now we can move this inside, but let me create here this counterbore with 2 diameters and so on. I have to place it on the center, so I create a sketch. I create a sketch by projecting this line up. Yes, you see there are 2 lines here. Why? Because I know that this is a diagonal which can be used to place a point in the middle. Finish sketch. As you remember, this was placed at 36 divided by 2, and this also is the line placed at 36 divided by 2. So this is the proper diagonal. Hole. You see counterbore with dimensions from the drawing of 29, tab, all, tab, 36, 2 millimeters. Okay, very good. This is tangent here, and here is a distance because this end goes here. Okay, modify, move bodies, this body 222 with plus. You see it will be inside. Okay, this volume is a solid and the other is another solid, and now we combine them to create only one volume. The base body is this one, the tool body is this one. Okay, now we have only one solid, number 3. Yes, you can look it inside from everywhere and you see that everything is okay. Now we create interiors. What interior? This is one with these dimensions. Let's create. We have no much time. F7, look inside, everything is okay. Line from the midpoint to the point on the vertical. So horizontal, and the last is here. Dimensions. First, let me create the coincidence here, then to make this construction line, and then diameters 36 and 30. This has the dimension of 14. Finish sketch. Revolve. Cut. Okay. You see the hole is where it must be. Inside here, I create a plane as follows. Reference is XY, and then I create a point by creating an axis of this point is at this intersection, and then the reference plane comes here. You learned this kind of creating constructions. F7, but I have to project this we draw a circle with the diameter of 20. We have to notice that this is not a circle. It doesn't have a center. It's a projection of this curve and this curve. Projection is a circle, of course, but we don't have a center. The same horizontal between these two, and the same vertical if I project superior circle, and then the same vertical between this midpoint and this center point. Now it is white. Yes, finish sketch. Extrude, cut 2 from this face to this hole. Yes. Okay. And then in the same plane I create a contour to be revolved. F7, and now I draw a line from this midpoint to this midpoint, and then a contour, a special contour with a sloped line, and then vertical, up and back. The contour is here. You see? Vertical, sloped, vertical, and this. Dimensions are in the drawing. We use them to place dimension in this sketch. Oh, let me make this center line. This is 10. The angle is 120 divided by 2. This diameter is 16. This dimension is 10. This diameter now is 30. These are collinear, and we trim this to have a connection point. A diameter of 20, and the distance from here to the opposite is 45. Now all is white. Revolve, area, axis, cut. Okay. Oh, only there is a problem with the last line. Let's see what it is. Double click on the sketch, F7, and there is something. Oh, this line is the problem, I suppose, because I selected only to that line. Let's create the threads. Here is not ANSI but isopipe threads, gauze 2. Yes, 2 inches. Plus this isopipe threads 1 3/4. Okay, plus ISO pipe threads 1¼ okay. Now there are some chamfers at every end of that threads, 2 on 45. Let's apply. 2 is by default. Which one? This 3. Okay. Another fillet, not radius, is here inside. Yes, let's create it, but we have no access. Look what I do. I go to view, half section view, this plane, fix it. Yes, now this is fixed, and I can apply to this curve a fillet of 3, and also to this contour. Okay, very nice. Where are other fillets? As you can see, outside, here, here, and also here, of course. Let's apply 3, yes? Outside this contour with 3, this contour, up, this one, also here, here, and where else? That's all. Yes, that's very all. Good. Okay, now we want to renounce to the half section view. We select end section view. Yes, the last feature is this flange with holes. Yes, there are no other holes. No. What is the problem? Diameter of 10.5, 4 of them. The first one is placed at 45. The diameter is 70. We go here, we create a line at 45 with a radius of 70 divided by 2, tab 45. At the end of the line we place a geometrical point to make a hole, not counterbore and not through, but to this face. What is the diameter? 10.5. And then we apply circular pattern on this feature about this axis with 4 instances. Not all, because I suppose this and this must be, this object is cast object, so every sharp edges and mold are to be rounded. You know. Assign material, steel cast, general aspect steel cast, and some faces are machined like this. Maybe this too, I don't know, but I suppose. Then inside this one. What else? Here the face and the interior, and also face, chamfer. Let's make chamfers machined, because they are machined, of course. All of them to be still polished. F6. If you want to see the part from here, you are free to change the angle of view. Properties. Physical update 3 kilograms. Close. That's all for the moment. Thanks for watching. Bye bye.